Okay, so I certainly hope I do not need to swap displays with this. The last couple of days in class, I haven't needed to swap displays. The students have said that even starting from the middle, it's working just fine. So with that in mind, we will continue our work with quadratic equations. We talked about how they look like a parabola, kind of like an arch, gentle shaped U the other day. And we talked about how if you always got the simplest ones like this guy here, x squared equals 9, we'd say, oh, this is easy. You could square root both sides and just say x is equal to plus or minus 3. But what if, what if it looked like that? Then we needed a strategy to do it. And that's where our factoring skills really came in to help. So what we do is we factor each of them. So I will go through a lesson on the first two questions, and then we'll have you practice a bunch. So the first one is already set equal to 0, so we need to factor it. I'm going to pause just a couple of seconds on my end. You can do stop and start and go ahead factor it. So when we factor it, we get x plus 4 times x plus 5 equals 0. Now let's do a quick mental check. X times x is x squared, x times 5 is 5x's, 4 times x is 4x's, add up 5x's and 4x's, you get 9x's, and 4 times 5 is 20. Okay, so that's looking good. Now, this binomial, this thing, if you will, on the left times this thing on the right is 0. So that means that one of them has to be 0. The only way to make 0 through multiplication, the product, is if one of the terms is 0, or both. So maybe it's the x plus 4, or maybe it's the x plus 5, or maybe it's both. So I solve each of them and I get two potential answers. X is negative 4 and x is negative 5. And with a squared term, which makes a quadratic, that's where the name comes from, that means that you're going to get you'll have as many as two possible answers. So in this case, those answers are negative 4 and negative 5. Okay. Now, if I ask you what the difference between the first question and the second question is, at first it doesn't seem like there's an obvious difference, but it's pretty straightforward. On the first one, it says equals 0, and on the second one, it says equals 18. We always, if we're going to factor, we always want it to say 0. So we subtract 18 from both sides, and we get x squared minus 7x minus 18 equals 0. And now I do it the same exact way I did the previous question, which I will pause to stop and start on your end and take it all the way to the end. Conclude. Go ahead. Okay, so we're going to factor it. Quick mental check. X times x is x squared. X times 2 is 2x's. Negative 9 times x is negative 9x's. And negative 9 times 2 is negative 18. Then maybe it's the guy on the left, maybe it's the guy on the right. On the left one here, add 9, subtract 2 on the right, and I get x equals 9 and x is equal to negative 2. And by the way, if you checked it, it would work. I'll just check the 9. 9 squared is 81, 7 times 9 is 63, 81 minus 63 is 18. Okay, from beginning to end, you do the last one. Okay, so first we subtract the 12, then we factor. Quick mental check. X times x is x squared, x times 4 is 4x's, negative 3 times x is negative 3x's. Negative 3x's and 4x's do add up to 1x. Negative 3 times 4 is negative 12. Okay, maybe it's the guy on the left, maybe it's the guy on the right. Adding 3, subtracting 4, x is 3 and x is negative 4. Okay, so those are your fundamental type of quadratic equations. But things can get a little bit more involved. For example, these three. Okay, now the only difference between the two that we just did in these three is in each of these, the lead coefficient is not 1. So you're going to look for a greatest common factor that you can factor out. Pardon me, let me backtrack. First, you get it all on one side. Then you look for a greatest common factor that you can factor out if you can. And if you cannot, then you go with plan B. So let's see you try just the first one from beginning to end. Go ahead. Okay, so first thing we need to do is make it equal 0. So we subtract 9x from both sides. Remember your standard polynomial order. 2x squared minus 9x plus 10. Now, there is no greatest common factor on this guy. So what we're going to do is plan B. We're going to multiply the last term by the lead coefficient of 2. And that gives me x squared minus 9x plus 20. Then I factor that. X minus 4 times x minus 5. Notice I'm not writing equal 0 here. This is kind of like scratch work. I'll get back to the equal 0 in a minute. X times x is x squared. X times negative 5. Negative 5x's. Negative 4 times x is negative 4x's. Negative 5x's and negative 4x's add up to negative 9x's. Negative 4 times negative 5 is 20. Maybe it's the guy on, oh, and then I have to go back in and divide by the 2 I multiplied by, which gives me x minus 2 times x minus 5. Maybe it's the guy on the left, maybe it's the guy on the right. Solving on the left-hand side, it solves pretty quickly. We add 2, we add 5 on the right. But here's the thing about the right-hand side. It does 2x, it doesn't say x equals, so we're not done yet on that right-hand side. We divide by 2, I'm sorry, and I get x equals 5 halves. So 2 and 5 halves are the answers. When we get a lead coefficient other than 1 here, you can't just kind of switch or reverse the signs like we did on the previous slide. It doesn't work like that. So if you started taking some mental shortcuts, like for example, you look on the first one here where it says x minus 2. Some students, they'll see the pattern and they'll say, oh, the answer is just 2. So they'll see the factor, they won't do the work, and they'll just put down a 2. But if you do that on the right-hand side, the right-hand factor, and you say, okay, well, that's 5, you would be wrong because you've got to divide by that 2. That's why we take the time to show those steps all the way through. Okay, try the second one. Okay, so on the second one, get it all on one side, put it in standard polynomial order, right? Subtract the 18, add the 3x. That gives me 3x squared plus 3x minus 18 equals 0. And this one, ding, 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 this is a good thing. They all share a 3 in common. So let's factor out that 3. That leaves me with x squared plus x minus 6 equals 0. Don't forget about that 3 now. I factor, and I get 3 times x plus 3 times x minus 2 equals 0. And now it's a strange thing. We have 3 things that when you multiply get 0. So maybe the first term is, maybe the second term, maybe the third term, maybe all of the terms, maybe 2 of the terms, but at least one of them has to be 0. So maybe, I don't know why I wrote that a second time, maybe it's the 3, maybe it's the x plus 3, maybe it's the x minus 2, not plus 2. That should say x minus 2. Let me go correct that. Oh boy, I'm going to take a chance here. Here we go. Okay. Here we are. I just copied it over wrong. I had it factored right. Simple, sloppy mistake, of which I am, or at which I am excellent, as I make plenty. Okay. All right, so let me get back to sponsored program. All right, so there's my factors. X plus 3 times x minus 2. I'll repeat it. Now, maybe it's the first guy, maybe it's the middle guy, maybe it's the guy on the right. And, well, that first one's ridiculous, so we can cross that off. It's impossible, so I don't need to consider that anymore. I did investigate the possibility. It just can't ever happen, so it's impossible. We can ignore it. Subtracting 3, adding 2, I get x equals negative 3 and x equals, I didn't fix it all the way. That should say positive 2. X is equal to positive 2. Okay, now the one on the right, get it all on one side, take it from there. Go ahead. Okay, so I assume your stop and start is now done. We subtract 3 from both sides. That gives me 4x squared minus x minus 3 is 0. There's no common factor here. So let's do plan B. Multiply the last term by 4. That gives me x squared minus x minus 12. I'm not writing equals 0 here because I'm kind of doing scrap work. I factor that. I get x minus 4 times x plus 3. You can pause and check if you wish. I got to come back in and divide by 4. Why did I do 3 over 2? This is to show you how a professional handles an emergency situation. Okay, and you know what happens is it's all done from I just copy this over from previous slides, and sometimes I forget to change the numbers on the bottom there. So, but it is now all corrected. Back to our regularly scheduled program one more time. It's like we had one of those obnoxious winter weather warnings on TV. Okay, so it was x minus 4 times x plus 3. Now I have to divide back in by the 4. And now I get an x minus 1 and a 4x plus 3. Solving the one on the left is pretty easy. Add 1 to both sides. On the right, don't go shortcutting this guy. Subtract 3 from both sides. X equals negative 1. Oh, positive 1. My God, my ability to make sloppy mistakes here is mind-blowing. X is equal to positive 1, and on the other side, x equals negative 3/4. So this should be positive 1. Why in the world it says negative 1, I do not know. But positive 1, negative 3/4. Okay. Now we go to the quadratic formula. This is the last new thing for today, and we're going to do 3 examples. This is actually a pretty famous formula. I remember being in college. So when I was in high school, the last math course I took was calculus, and I went to college and I took a higher level of calculus. And I remember the very first day the teacher said to us, Professor Lance, he said, "What's the quadratic formula?" And I had not looked at the quadratic formula in many months. And I just remember very slowly in my mind saying, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's just the kind of formula that sticks with you and remembers, or you remember it. And back in those days, we used to actually have to remember these formulas. Nowadays, you don't need to remember them anymore. They let you have them. So, what are A, B, and C? A, B, and C are always the numbers in front. So A is the number in front of x squared, B is the number in front of x, and C is the number at the end. So we need you to figure out, or to list, what the values of A, B, and C are in each of these. So let's just do the first one. What's the value of A, what's the value of B, and what's the value of C? Okay, so on the first one, remember, A is whatever's in front of x squared. When it equals 0, see how the general formula has to equal 0? So we make it equal 0. So A is 1, B is 7, because B is whatever's in front of the x, and C is the constant at the end. It's negative 19, not positive, just kind of like the y-intercept there. It's negative 19. Okay, now you're automatically starting to notice the problem on the middle one, and for that matter, also the one on the right. Yeah, they don't say equal 0. If they don't say equal 0, you need to manipulate them to say equal 0. So, in this particular case, oh wow, that went backwards. You needed to subtract 8x from both sides, and then A will be 1, the number in front of x squared. B would be negative 8, the number in front of the x, and C will be 14. Okay? Now, you go from beginning to end, manipulate the next one, and say the values of A, B, and C. Go ahead. Okay, so I manipulate it by subtracting 11x and 10 from both sides. That gives me 5x squared minus 11x minus 10 equals 0. So A is the number in front of x squared, it's 5. B, the number in front of x, which is negative 11. And C, the number at the end, which is negative 10. So now that we can identify A, B, and C, let's actually use the quadratic formula to solve. So let's do this first one together. First thing I ask you to do is figure out what are A, B, and C. Again, these are the same questions we did before. A is the number in front of x squared, so it's 1. B is the number in front of x, so it's 7. C is the number, the constant at the end, it's negative 19. So here is our work. All we have to do is substitute everything in place. So the formula up here says negative of b, but b is 7, so it's negative 7. Plus or minus, square root of, none of this changes. B squared, b is 7, so 7 squared, minus 4 times, and I really like doing this in parentheses, okay, so that your calculator doesn't have an issue. A, which is 1, times C, which is negative 19. If you have a graphing calculator, which we have strongly recommended, you just type it in exactly the way it appears, and it will tell you the value. All over, 2 times 1 is 2. Now, I would just do the radical part by itself, and I'll explain why in just a minute. This is negative 7 plus or minus, and if you add 49 and 76, I get 125. So that's negative 7 plus or minus the square root of 125 over 2. Now, it is possible to simplify the square root of 125. I'm not going to get into that with you now. If you recall how to do it from your high school days, that's great. If you don't worry about it. We'll consider that. Even though technically it is not in simplest radical form, we're not going to take this any further, okay? If you were a math major, I would absolutely be making sure you took it further. But for our purposes and the material we need to cover, we're not going to go there. Okay, so that means that there are two potential answers, and those two answers are given by this plus or minus here. The first answer is negative 7 plus the square root of 125 over 2. And the second one is negative 7 minus the square root of 125 over 2. And I just typed that into the calculator. The square root of 125 is 11.2. So negative 7 plus 11.2 is 4.2 over 2. And negative 7 minus 11.2 is negative 18.2 over 2. Simplifying, 4.2 divided by 2 is 2.1. And negative 18.2 divided by 2 is negative 9.1. So now, in summary, there are two ways I can do the quadratic formula with you. One way is I can ask for the answer in simplest radical form. And again, let's not go crazy over that square root of 125. In radical form, this isn't simplest, but in radical form, it's negative 7 plus or minus the square root of 125 over 2. In decimal form, all I do is take my calculator and figure out what the square root of 125 is. We rounded it off to 11.2. And then I have two things to do here. One is negative 7 plus 11.2. That was 4.2. The other is negative 7 minus 11.2. That was negative 18.2. Divide both by 2. And that gives me 2.1 and negative 9.1. Okay? All right. So on the next one, remember to subtract 8x from both sides to get your values for A, B, and C. And then we will solve the quadratic formula that results. Go ahead. Take it from beginning to end. Okay, so when I subtract 8x from both sides, I see that my values are A equals 1, B equals negative 8, and C is equal to 14. I put that into my quadratic formula here, and I'm going to get, see, I just forgot to change the negative 7, but I did down here to 8, so we'll leave it there. B is negative 8, and the negative of negative 8 makes positive 8, plus or minus the square root of, and then negative 8 is going to be squared, minus 4 times 1 times 14, which is negative 8 squared is 64, minus 4 times 1 times 14, which is, oh man, at least I'm going to get it straightened out. This is going to be 8, and this is going to be minus 56, right? You know, 64 minus 56, which makes this 8. Square root of 8 is 2 point what? Second square root. So you get to see me do the work anyway. 8, enter, 2.8, which would make this 10.8, and that would make this 8 minus 2.8 would be 5.2, which would make 10.8 divided by 2 is 5.4, and 5.2 divided by 2 is 2.6. All right, let's go with play from. Okay, there's the first one. Now we're on the second one. Okay, we mentioned that we needed to subtract 8x from both sides, so x was negative 8, or b was negative 8. So here it is. The negative of negative 8 is 8, plus or minus the square root of b squared, which is negative 8 squared, minus 4 times 1 times 14. 4 times 1 times 14 is 56, and negative 8 squared is 64. So I get 8 plus or minus the square root of 64 minus 56 is 8. The square root of 8 was 2.8. 8 plus 2.8 is 10.8. 8 minus 2.8 is 5.2. 2.8 divided by 2 is 5.4. And 5.2 divided by 2 is 2.6. If they asked you for radical form, there's my answer. It's not simplest, but it is radical form. And for our purposes for this course, that's good enough. And if they ask decimal form, it's 5.4 and 2.6. Okay? All right. Let's take a look at the next one. And first, let's see you try to get it equal to 0 so we know what the values of A, B, and C are. Go ahead. All right, let's see what you come up with here. And I would be subtracting 11x and subtracting 10. So A is 5, B is negative 11, and C is negative 10. Okay. So let's have you work on that. And while you're working on that, don't look up because I actually have a correction that I need to do on this as well. The correction does not affect the answer because in the answer it worked out fine. Actually, no, it did not. So it does correct it. So I'm going to fix it while you're working on it. Go ahead. do a bunch of stuff here. To catch up. Okay. So if you are not done, pause this and then get done, and then we'll go over it. All right. So we said that the value of b was negative 11. So the negative of negative 11 is 11, plus or minus the square root of b squared. Negative 11 squared is 121 minus 4 times a times c, and that works out to be 200. So under the radical, 121 plus 200 is 321. And if I want simplest radical form, there it is. Okay. It's also, for our purposes, radical form, 11 plus or minus the square root of 321 over 2. And then if I want to do as a decimal, I do 11 plus or minus 11.9, because that's what the square root of 321 is, over 2. Notice I put that in parentheses, so it's the whole thing over 2, which is 22.9 divided by 2, or negative 0.9 divided by 2. And I actually went out to 2 decimal places on this one. Any question on a quiz or test, it would tell you. I have 11.45 and negative 0.45. So that is how you use the quadratic formula. Sorry about my sloppy typing in places, but at least we have it all corrected, so now you can follow it through cleanly. The happy recap. What are the steps involved in solving a standard quadratic equation? Set that trinomial equal to 0. Factor, solve. And in the case of the quadratic formula, you want to set equal to 0 and substitute for a, b, and c. Crank out those calculations. Then you got to ask yourself, how do they want the answer? Do they want radical form or do they want decimal form? That determines whether you convert it to a decimal. All right, have a great one.